Hey, Wheaton North. Today I'm going to talk to you about electronegativity and reactivity. Are two trends that atoms have that are easily explained if you have a good handle on nuclear charge, shielding, and atomic radius that we've already talked about. So starting off with electronegativity, the atom's ability to attract a bonding or shared pair of electrons. So we're talking about valence electrons and the atom's ability to pull those valence electrons towards its nucleus. So that's the definition of electronegativity. As you go down a group, we've already talked about every time you add energy level to an atom, the atom gets bigger. All those additional inner energy levels are going to act as shields that are repelling the valence electrons away from the nucleus. So the more shields there are between the nucleus and the valence electron, the harder it is for the nucleus to pull on those valence electrons. So as you go down a group, the electronegativity value will get smaller. And remember, the electronegativity is basically the atom's strength. So bigger atoms are weaker atoms. As you go across, we've already talked about how atoms get smaller as they get across. They have the same amount of shielding because we're adding a proton to each of these atoms. Their effective nuclear charge gives them a stronger ability to pull on valence electrons. So we went through this in the atomic radius, so if you need more explanation on that, go back to the video. But this is the exact same concept. If bigger atoms are weaker, then the opposite is true. Smaller atoms are stronger, so they're going to have higher electronegativity values because they have a greater ability to pull electrons towards themselves because they have more protons. So, bigger atoms are weaker, smaller atoms are stronger. That's the easiest way to remember all of this. All of that electronegativity stuff leads us into reactivity. Now, reactivity is different depending on what kind of atom you have. If you are on the left side of the periodic table, we're calling you a metal. They have very few valence electrons, so they are going to lose them. They have a lot of shielding compared to their proton. They have very low effective nuclear charge. Usually it's just a +1 or a +2, so they're not very strong atoms. They're very big for their size. Remember, the farther left you are and the farther down you are, you're bigger. So it's going to be easy to steal electrons from you, which is good because they need to lose electrons to become stable. The right side of the periodic table are nonmetals. Those need to gain electrons to fill in those empty spots. Smaller atoms are stronger. Chlorine is all the way over on the left side. It has the highest effective nuclear charge in its row. It's really, really strong. Even though it has the same number of shields as sodium, it's way stronger than sodium because it has so many more protons. So it can pull all of its valence electrons really close to its nucleus, and it won't just pull its own valence electrons, it will pull sodium's extra electrons too, because sodium sucks at hanging on to it. That's electronegativity leading us into reactivity. So really quickly, just as a quick review, if you didn't get this earlier from one of your teachers, because I know I forgot to tell my students, metals are on the left side of the staircase, nonmetals are on the right side of the staircase. Going way back to the ion videos, we've talked about how metals are losing electrons to become positively charged. Nonmetals are gaining electrons to become negatively charged. If you want to gain electrons, you have to be strong. To be strong, you have to be little. So reactivity. Metals are more reactive when they're bigger, because metals need to lose electrons, and it's easier to take electrons from bigger atoms. Nonmetals are more reactive when they're smaller. They need to gain electrons to become stable. They will be more reactive when they have a higher electronegativity value. So these arrows talk about reactivity, but these arrows also kind of correspond to atomic radius. Atoms are bigger the farther left they are and the farther down they are. So metals are more reactive. The closer you are to francium in the bottom left-hand corner of your periodic table, the more reactive you're going to be. Nonmetals, the smaller you are. So you get smaller as you go across, and you're smaller as you're higher up. The closer you are to fluorine, you're more reactive. You'll notice that this shows no reactivity. Remember that last column are noble gases. They already, as in their neutral state, have full valence energy levels, so they don't need to interact with anybody. Electronegativity is the measure of pulling shared electrons towards your nucleus. And these are never sharing electrons, so you cannot measure something that never happens. So they have a 0 electronegativity value, whereas the ones right next to them have a really, really high electronegativity value because they are really good at pulling in. They have 7 valence electrons, they're going to pull in 8. Alright, so that kind of sums up some of our big trends that all go together. Nuclear charge and shielding helped explain atomic radius. Atomic radius helped explain electronegativity, which explains reactivity, so they all go together. You have a few worksheets to help you work through electronegativity and atomic radius, and to help you practice figuring out which one will have more and less. Your teacher's going to show you an awesome demo on reactivity of metals, so I hope you're looking forward to that, and good luck mastering these trends.